right? Plug this one over there, then I will obtain PSC, sorry, this has to be SC. Dot N is equal to gradient PI dot N minus, and I know this is minus d pi dn, right? And this is what? This is minus b, taking derivative with respect to r force, that will give me j k dot r, no, jk dot n and this is what? If I use, this is n vector, theta, this is x, and this is y, that is simply k. What is this? K dot n. What is this? Inner product. Inner product simply means the magnitude of this vector multiply magnitude of this vector and multiply cosine the angle between this, right? So that is cosine. That's it. Multiply k, right? And that is, see. Now, this one has to be same as this one. And it is interesting that if the scatterer is a sphere whose radius is a, then this term would be k a in normal direction cosine theta, right? So the velocity, the velocity related, that is related with this term. This is related with the velocity, right? Velocity has a two terms. One is associated with omega over c and cosine theta, and the other one is associated with this term. And if Ka is very small, meaning that wavelength is large compared with the scatterer's size, then exponential this term can be approximated as 1 plus j Ka cosine theta. Right? Okay, this is the highlight. This is the highlight. Now I can argue that scatterer has velocity, this term multiplied by 1 plus j cosine theta, Ka cosine theta, when wavelength is large compared with A, right? In other words, the wavelength is very large and coming in this direction to this scatterer, and the wavelength is lambda. Okay? Then the velocity our scatter has two components. One is, looks like a cosine theta. That means this is 0, theta equals 0. So there's some magnitude, and this is cosine pi over 2, so therefore this is 0. Right? And then over here, cosine 180, that has a different sign, so this means the first term is oscillating like this. Right? The velocity distribution of the scatterer has this profile. Okay? This profile is changing due to exponential minus j omega t. Okay? Then this one go here and this one go there. Right? So the first term look like radiating sound in space by this velocity profile. And then on the other hand, the second term has cosine theta again, therefore second term has a cosine square theta. Therefore the velocity distribution of the second term is look like this. Therefore, due to exponential j omega t term, this second term has positive, this direction, and then negative, positive, negative, positive. So, second term, certainly that scattered field is due to trembling breathing sphere behavior.